One.
Still waiting. Starting. Okay. Welcome everybody. My name is Tom Breza. I am the host of C++ London Uni. First of all, thank you very much for coming. Today, as I say, we are a bit like the sardines. Now, the reason why we are a little bit like sardines is because apparently there's a dropout rate, and they assume we will be by default 20 people. So if quite a few people drops, they say, oh, you will be fine here. But the other meetups, they might get a bigger room. But if they see, let's say there's like a couple of days beforehand, if there's like more than 20 people trying to get to the class, they might switch us to the bigger room, and the other meetup put to this room. So, the good suggestion for you guys and girls, please do RSVP sooner the better, because then it's nicer, because we're almost like having no air to breathe, and 2 hours later everybody will be falling asleep. So that's me ranting. Sorry about that. The next thing is it's a light one. A fun fact: 2 months ago we had 3.5 thousand minutes streamed of our class, and last 28 days we had 8.4 thousand minutes. So we had like a almost 3 times over increase in basically over last month. So I think we are on the right track. We have over 436 subscribers to the day. Obviously, if you don't subscribe to our YouTube channel, please do, because pretty much all our classes from the past are being recorded. So if you want to get anything to get to repeat, or some class like we had with Phil Nash, the author of Catch 2, that's the first place before we get him back. Now, standard thing, our classes are every Tuesday, yes, and most of the time we are in Skills Matters. If we are in Skills Matters, please do RSVP at their website, yes, because they will not let you inside the building. However, if the workshop or a class is happening, let's say at Mimecast or somewhere else, do RSVP on our website, so we can print the badges and let's say for the workshops. Yeah. So what's the workshop? Workshop is basically probably as important, maybe even more important part of your training, where you meet up, let's say at Costa or sometimes here, depending on the availability, and you will try to put the knowledge which you gain on the last class into practice. Because when Tristan explains, everything seems to so that simple, but when you try to put that actually in a real life, then it becomes another cut.
I'm not sure that everybody thinks it's dead simple when I explain it, but
I assure you it is. But when then you try to use it, it's not. So the classes basically are on Tuesday. We're just trying to show you the material, and workshops are on Thursdays, and we just try to do the work. Yes, the important part is to register, to do RSVP for the both of them, because on Thursday, we asking like experienced developers to pop in and give a hand. So if you're stuck, somebody who had good experience can give you a hand. But if we don't see anybody coming, let's say on Thursday, then obviously the experienced developers will not bother to come. Or if they come and there's nobody there, even worse, because they say, well, these guys are joking. I wasted half of my evening and it's nobody there. So please do, it's important. If you want the latest updates about what's going on, follow me at Twitter. My handle is xxvms. And I post there about our meetings.
Why don't you change it to something meaningful like Tom Breza?
I don't know. I like training people memory, maybe. I started a long time ago. I'm probably too lazy to change that. And anyway, too many people, it will be confusing. I have a bunch of licenses for CLion. So if anybody needs extension to CLion, I have 6 months licenses. Send me an email. If you don't have my email address, approach me and I'll give it to you. In a subject line, put CLion license. In the body of the email, put your name, your surname, and your email address, so I can easily copy and paste, and off you go. You got it. Now, very important part. Please do not ignore it and listen to this. Tristan is preparing. Tristan, you close your ears. Tristan is spending pretty much a lot of time using his Mac very much to do the slides and for you to learn. Now, the important part is his Mac pretty much died. So what we're trying to do. So what we're trying to do is to raise the money from people who do benefit. Yeah. So if you don't benefit, if you didn't think like obviously we're not asking you for commitment to do anything. But if you do, and that's helping you with your job, get a promotion, get a new job, help us. Yeah. We want to buy this guy a Mac. We are almost there. I think like 40% there. So we have a few generous people. Please do go to this address and help.
Sorry, do you want to? We're very, very short on space, but if you can find somewhere to sit yourself.
If you need to ask somebody from the guys, they'll help you. After this class is finished, we are going to Beer Schanke for a couple of beers. Everybody is welcome, and sit down, grab a couple of beers. Buy Tristan and Ollie a beer to make sure that they don't have to buy their own drinks there. And then we'll see you on Thursday. So that's all from me. I hope you will enjoy. Speaking of devils, he just arrived. I say welcome and learn something new today.
This is cozy, isn't it?
It's very cozy. This is because of people who don't have, like me, written thingy.
I was never RSVP, so it was full.
Yeah, I got the same.
So
I had to be put on the waiting list, which could have left everybody else waiting. But anyway, here we are. Welcome, everybody. Thank you for coming. Apologies for the fact we're so crammed in this week. If everybody can go and for next week and the week after, just go to the Skills Matter website and register, and then hopefully they'll put us in a more appropriate room for this group size. I hope everybody can see the screen. It's a bit mini compared to what we usually have, so if you can't, then sort of, yeah.
so glad I can do it. On the mic, this is a bit of a isn't it really?
It's a bit of a pain.
I'm over this side, and there's.
You're going to be right in front of the
I thought there
screen.
was a chair that I could move out, but there's not a chair. So.
No. Right, so let's get started. This is, so for the majority of you, I imagine you've been here before. This is a module we're calling Initial C++, a very sort of from basics, assuming nobody knows anything about C++ from the start. This is now the fourth session, the fourth week we're doing this. So who's new tonight? I know there's one person, two of you. So yes, this is session 4. The first 3 sessions, all the slides are on our GitHub page. You found them? Yeah, awesome. And also the talks are all streamed on YouTube. So as Tom was saying, if you go to our YouTube channel, you'll be able to listen to me talking. Just put it on double speed, it's much easier. I don't know where those are going to go. Yeah, unless we start sitting on the table.
That was my idea as well.
I can squeeze in this middle.
Yeah, that's
push it.
one year. You said you can't move it.
Careful.
Don't drop it. What are we doing?
You're going to be nicely in the way of the screen there for a bit.
Well, yeah, where's okay where I'm not playing? How's this?
I don't know. You have to sort of slouch. Okay.
I should have asked them if I'd have known this. Gosh, Minecraft this week.
Well, we didn't know.
We didn't and stuff.
Okay, so for those of you who have been here before, you will have seen this slide. For the newcomers, we do like hearing from you. We like feedback. We have a Slack channel that we can. So if you know what Slack is, you're familiar with Slack, yeah. So we have a Slack channel. It's technically private, I guess, but you can, if you go to this URL, cppland.now.sh, you can put your email address in and they'll send you an invitation to join it. And then we've got our room in there, #CPP London Uni. And you can talk to us and you can talk to other people who are following us from all over the world, which is quite interesting. And yes, please do that. So this is a bit strange because I have to lean to see the screen. But anyway, we'll make do. So last week we went over quite a bit. We didn't actually learn much new C++, but we went over quite a bit about how the compiler works, how C++ programs are actually built, and we also tried to get everybody set up with a compiler and with C-line. So hopefully everybody's done that and they're all ready to go, because I'm going to assume that for the lesson today. So if you're not, all the instructions are in last week's slides, so please go and have a look at that. So what's on the menu this week? We're going to be talking a bit more about how the language actually works. We're going to be talking about value semantics and passing by value, which are very, very important, but slightly different if you're used to, say, Java or something like that. C++ works a little bit differently. We're going to be talking about scope, what that means and why that's important. In particular, as it controls object lifetimes. And then we're going to get into some bit of control flow, so if statements and loops. So that's on the menu for this week. First of all, last week's homework. So who managed to have a go at this? Oh, quite a few of you. Excellent. Who was successful?
I didn't do the last extension.
Didn't do the test.
I didn't do the extension.
Okay, well, that's awesome. So well done. Oh yes, Tom mentioned it briefly, but I should probably say, again, for the new people. So we have our classes, these sessions on a Tuesday, which is, primarily me talking and going over slides and things. And then on Thursday evenings, we have more of a practical session. So people come together and hopefully work on the homework, or you can work on whatever you like, I suppose. But the idea is that we get everybody together and we can really help each other, and everybody gets to do some practice. So I've said this several times now, but the only way to get good at C++ or any other programming language, or really anything, is by practicing it. So if you want to learn to play the piano, the only way you're going to get better at it is by practicing the piano. And it's the same with programming. So as Tom said, the Thursday sessions are just as important as these ones. So if you can make it, please do come along. So on Thursday we are at...
Mostly we are at the Costa, which is just the opposite.
So literally across the road from the front door here. We all meet up in the cafe.
But there are sometimes a day where we'll be here. We'll have a one table there. Yeah, pretty much. Just check our website. There's I put a big list of the dates with the classes and workshops. Do you know, anybody knows our website? Hands up, people who know.
Yeah.
Okay. And hands up, how many people check this every once a month? Okay, please do check once a week, yeah? So then if we change anything, at least you get it. Okay, so the solutions, my solution anyway to the homework exercise, you can find it at that URL. I will just very briefly go over it because somebody asked me to, which is going to involve me craning my neck to look at the screen. So I'll give it a try. Ooh, the latest iOS.
Yeah. Okay, so I asked you to call them Fibonacci.cpp and Fibonacci.hpp, so I failed my own homework, so never mind. So first of all, let's have a look at fib.hpp. So in here, you can see we've declared this function called fib, and it takes as parameters an int called n, and then, which is how many numbers we want to generate, and then two seed values. So I've called seed 1 and seed 2, and then I've added default parameters. So this means we can call fib with one argument, and if we do that, these two are going to have value 0 and 1. We can call fib with two arguments, in which case the third parameter is going to have a value 1, or we can specify all three parameters. And we return a vector of ints.
Very quickly, Tristan. So when you're passing values into the function,
Yes.
what if you forgetting the default values, just a general function passing 3 ints to?
Yeah.
What if you just pass one value and you don't pass it in? What will happen?
Then it will tell you there's no matching function because it's looking for a function with one argument it's looking for a function with one argument because that's what you've called, but the only available one has 3 arguments, and it will probably tell you I couldn't call this because this requires 3 parameters and you only gave me 1.
But what if you then say comma and then left blank and then comma? Would that do anything? Would that go through? So
That's not going to work because you can't not pass an argument, if you see what I mean.
Right.
If you have to specify something. Yeah.
2 questions. Does it matter, you say the default values, does it matter which one you don't pass? In other words, could I say put the value for int n and seed2, but ignore seed1?
No, you
Or
can't.
will it freak?
No, you can't. So you have to specify them you have to start omitting them from the right first, if you see what I mean. Right, so you can either pass one value, in which case these two are going to get the default. You can pass 2 values, in which case this one's going to get the default, or all 3. You can't just specify values for the first and third arguments.
Okay. Secondly, what's vector int as opposed to int on its own?
So an int is just an integer value. And a vector is a very, very useful, probably the most useful type in the standard library. It's a container of whatever type is in the angle bracket. So this is a container of ints. And vector in particular is implemented as an array, so it's very fast, contiguous in memory, very good cache locality, all of that. But it's also growable, so you can add more things to the end of it, and it will take care of resizing itself and looking after all the memory for you, all the memory management. So it's basically what other languages would call an array. It's absolutely nothing to do with a mathematical vector. The name is confusing. I don't know why they called it vector, but that's what it is. It's what other languages would call an array.
So how do I access that component within the array?
Oh, so you'd use the square brackets operator. So you'd say the name of your
Array.
yeah, and then you put square brackets, and then you put the index, counting from 0, the index of the element you want to
So you
access.
define the array and then put so many elements in the array and then...
And then you can get access to them later using this square brackets operator.
Great, thanks.
And to use this, because it's defined in the standard library, as I was saying last week, we need to use this include statement with angle brackets because it's not from our program, it's from the standard library, it's from an external library, so we use angle brackets and we say we want the vector component. And usually most headers would have .hpp, but here because it's a special one, it's part of the standard library, it doesn't have an extension, so we just say include vector. Can we zoom in?
Right hand, top right. That's it.
So that's our header. Let's have a look at the implementation. So the first thing is we include the header. So in your implementation file, you always need to include its corresponding header first. And now we have the definition of our fib function. So it looks just like the declaration, except you notice we don't have to put the default values again.
So, Mr. where you are exactly?
I'm sorry.
Where exactly are you looking right now?
Where?
There.
The URL is at the top, but it's quite small, and I don't know how to get it.
We can copy and paste this to slide,
If you
maybe?
look in bigger, it's course materials week 2 homework solution pib.cpp, so you can browse.
Yes.
A question from the internet. Does vector have any forward include variant, or must one always include in the form of the .h? when one uses a vector in a function signature?
There is no forward include. In fact, it's illegal to forward declare the vector class. You have to use hash include angle brackets vector.
Okay, my question is motivated by compilation speed and the general understanding that one's translation you need to complete faster when one includes fewer files from one's headers.
That is true, but with vector, in fact, with all the standard library classes, there is no alternative. You have to.
One thing you can save on is template instantiation. You can explicitly instantiate whatever types you want to template the vector of, and then use an external template for other locations. So even though you still have to include it, you prevent the compiler having to generate multiple template instantiations if you really care about performance that much.
Thank you.
Compilation.
Okay, so let's get into our actual implementation. Oh yes, so I was saying, notice we don't have the default arguments here. Those are part of the declaration. They're there because code which only looks at the declaration, so it just knows how to call this. It knows that this has default arguments, but we don't need to restate them here. Okay, so how does this function work? Well, first of all, we declare our output vector, and then we immediately insert 2 items into it, the first 2 seed values. So this pushback is a method on our vector class. So this just inserts items into the vector. And then we've got this for loop. So what this does is we're going to go over loop structures later today, but what we do is for every value of I from 1 until n minus 1, we, first of all, this is the square brackets operator, so first of all we access the element I minus 2. So remember, I is starting from 2. So we do I minus 2, we're going to get 0. So on our first run through, we're going to get 2 minus 2, so that's going to be 0, and that's going to be element number 1. And then our second time through the loop, I is going to be equal to 3. Sorry.
Yeah, element number 1 is the second element.
Yeah. So everything in C++ counts from 0. So when we're accessing elements, the first element is element number 0, the second element is element number 1. Right, so this is when you're starting off, this can be quite a common error. So common it's got a name, an off by 1 error, is to think that your first element is element number 1. It's not, it's element number 0. People have endless arguments about which is better, but C++, we start counting from 0.
Could you have constructed this with C1 and C2 as initial elements already?
You could. So you could do that by putting curly braces after output and then inserting C1 and C2. I was just being explicit with the pushbacks.
The I minus 2 is accessing the position where that.
Yes. So this is access element at this index. Yes.
What does const int do?
So this declares a new variable of type int, which is a constant. That is, we can't change it after initialization. So it doesn't actually make any difference in this case because we're not trying to modify it, but it's basically just good practice to get into the habit of when you're not going to modify anything to declare that variable as being const. Yes?
When you define your standard vector, is that implicitly giving you just an empty vector?
Yes, it is. Yes, it is. So I could have, and probably should have, because I've told you it's good practice, just put an empty pair of braces there, and that probably would have been better. As it happens, vector is a class type, so we don't have to worry about it being uninitialized.
A very good question about
Yeah.
the header included in the implementation file. It's purely for the linker to know that these two objects are related.
No, we actually, strictly speaking, could get away with not including that. But the reason it's a good idea is because if we had a mismatch between our declaration and our definition, this would help catch it.
Right.
Yeah.
What does the plus plus after that?
The plus plus So this increments the value of I, so it adds 1 to it.
What's your question?
So,
Why is the header
yeah.
included in the implementation?
Wouldn't the compiler bark when you run that? Because you're not including vector.
Why are we not including vector?
When you're including in your header, I can assume that will do.
Yeah.
Ah, okay.
So the include mechanism is recursive. So we're including this, which in turn includes vector. So transitively.
If you're working on a big project with let's say 2 header files, and you're including just one,
Yeah.
then potentially you don't need to include it anywhere else. In your
I'm not sure I follow.
So let's suppose that you had in your folder you had 2 header files and
Yeah.
2 .cpp files.
Yes.
You have a Fibonacci function defining one set of files, and let's say an add function in that
Yeah.
one.
If you're not using the functionality of add, then you don't need to include the second header.
But
You only
you
need-
last week that for each type, whatever sort of functions are yours, like libraries they use, you should include them in each of the.
Include what you use.
Yeah.
Yeah. So in this case, our Fibonacci declaration makes use of vector, so we have to include vector.
Yes. So
Yeah.
when I did my example, I included in this implementation file include vector as well.
There's nothing wrong with that. It won't hurt, but it's unnecessary because our
The previous
Yes.
declaration has it.
yes, exactly.
Think of each CPP file as the root of a tree. So the compiler sees your CPP file,
Yeah.
so it reads that, and it will then read whatever it includes, and then it will read whatever that includes. The root level is a .cpp file, and it's that CPP file on its own. Okay, so if you have 2 CPP files, they are compiled separately,
Yeah.
and what they include is separate.
Ah.
Makes sense? Okay.
Yes.
I don't know if I'm being pedantic, but within that for loop, you seem to be redefining continuously constant last 1 and last 2. Wouldn't that freak it out?
I can see where they're coming from. That's good thinking. Actually, we're going to talk about this, well, just when we finish this. This is its own scope, so these last 1 and last 2 are recreated every time we go through
Oh,
the
that's within that scope.
Yes.
So
But we'll talk about that in much more detail very shortly.
They live within a single iteration.
Yeah,
okay, so that's a temporary sort of value in there.
so we grab the last 2 values that we were inserted into the vector. We know that there are at least 2 because we put them in there. So we grab the last 2 that we're at, and then we add to the vector the value of last 1 plus last 2. So that's the definition of the Fibonacci function. So we do that for n number of times. So n is the number of numbers, the counts that we were requested. So we do this until there are n elements in the vector, and then we just return the output. So we return this thing. I'll have a very quick look at test fib. So I've got a required vector, so these are the first few Fibonacci numbers, first 10 with the default seed. So here you can see I'm calling fib with just 1 argument, so the 2 seeds are defaulted to 0 and 1. So I've got required and result, and then I just test to see whether required is, so if result is not equal to required, we print an error, and then we return 1, so we return from int. Remember the convention is that int returns 0 if everything went well, so returning 1 is like a signal, if anybody cared, that something has gone wrong in this function. And we also print this error message.
You're comparing a vector to a vector?
Yes.
You can do that?
Yes, you can.
Oh, clever.
Yeah, as long as they hold the same type. So you can't compare a vector of ints to a vector of floats, but you can compare 2 vectors of ints.
Okay. And presumably you're comparing the same number of
So
elements.
first of all, it
same-
compares and makes sure they've got the same number of elements, and then if they've got the same number of elements, it compares each element to see in each position to see whether they're the same.
What would happen if you use dynamic casts if you try to convert the vector of ints to vector of floats?
It's absolutely not going to work.
It will compile.
Will?
And it won't run. If
Okay,
you use a pointer, it returns null pointer. If you use a reference, it throws an exception.
so now I've got a slightly more involved test. I just generated some Fibonacci numbers starting from a different seed. So in this case, I've called fib. Again, I want 10 elements, and I've set the initial seed values to 2 and 4 rather than 0 and 1. So that generates this Fibonacci sequence. Trust me, it does. And then again, we just check to see whether the result that we got was equal to what we required.
Is that in the test file that's called from your main?
This defines main in this. Yeah. And then very quickly, this is not really C++ related, but as an extension, I asked you, can you create a library called libfibonacci or something like that? So all we do is it's not really that easy. So you have to, this is really CMake related, build system related. So if you're not...
I attempted it, but
so this was an optional bit of the... So what we're doing here, we're first of all saying this is the minimum version of CMake that we want. We're defining a new project, which is called Fibonacci, and we're saying it uses C++.
So is this within C line? You can obviously see your CMake text file, list file. So within that, is it the same project you do it, or did you create a...
No. So this is, so when you create a new project in C line, it will generate a CMake file for CMake list.txt. Yeah. You can edit that as you like. When you do that, a little bar will come up saying C line has noticed your CMake has changed. Do you want to update? And you click yes. So you can't use the C++ because it doesn't like the plus character, so it calls the language C++. It calls it CXX. Just think of it as a plus that's fallen on its side.
You don't actually need it. You can figure it out. Usually, in my experience with CMake, you have to define it when you're mixing languages. If I have like a mixture of C++ and C code, then I have to put CXX and C. Yeah. Usually, it will just figure it out if you don't figure it. If it's a single language. So
now we're saying we want to use C++ 14. That's all that line does. In fact, I don't think anything in this project actually uses C++ 14, but that's just the sort of default that we start off with in this course. Oh yeah, I did use a bit of C++ 11. But, so now this is just the way that I've chosen to do this. I've defined a variable, a CMake variable called source files, and this variable is a list, and it contains these two things, fib.cpp and fib.hpp. And then I've said I want to add a new library named Fibonacci, and the source files are contained in this variable. So to access things in this variable, you have to do this horrible dollar thing. And then I'm going to add an executable called test Fibonacci, whose source file is testfib.cpp. And then target, so this creates a target in CMake language, CMake terminology, called test Fibonacci. So I want to link my test Fibonacci target to my library named just Fibonacci. So that's what the target link library is. So you really, if you wanted to do this extra part, there was no way you were just going to do it off the top of your head. It would have required a bit of research into CMake, which is...
I got some websites, I was trying to look through it, but I still couldn't make it.
So if you did that one, very well done. If you didn't, don't worry, that was an extension, and this is a C++ course, it's not a CMake course. I just put that in there because if people really wanted to get into how this worked a bit more.
How is that used?
How?
Like if you did that.
Yes.
How would you
So this creates a Fibonacci library, which you can then use in any number of projects that you like. So in this case, we're just using it in our one little test Fibonacci project.
How would you call it?
Well, typically you'd install it somewhere in your system, and then other code, and you put that in a sort of on Unix anyway, in a sort of well-defined location on your file system. So /user/lib is the usual location for libraries on Linux, and you put the headers in /user/include, and then if you put the library in the headers in those places, the compiler knows where to find it.
So then you do the hash include, and then you can include that into your code.
Yeah. Okay. On Windows, it's a bit more complicated because everything's more complicated. Yes.
Purely out of interest, in a real world same situation where of your process? Because right now you're compiling everything and it's just your test and your actual code, compiling it all together. Would you split? I guess you would split the test and you compile them separately.
So this is compiling them separately. So because we now have a library, and
okay, so you're compiling your test as a library.
Yeah. So now, let's say we've set it up like this. If we now go and change some of our library code, it's going to recompile that library. But we don't have to recompile this. We just have to do the linker step. Assuming we don't change the header, we only change the implementation. All we have to do is relink here. We don't have
a dynamic library.
Yeah, we don't have to actually recompile our test.
And is that the standard way to do it?
It's a very common way to do it, yeah. So the idea behind this is that Fibonacci is just some reusable library that other people can use as well.
Makes sense. Thank you.
Yeah.
But also the test is executable. The library is not. You don't
Yeah,
can't execute a library.
Yeah.
The library exists purely to be used by other stuff, which may also be a library or be an actual executable.
But then isn't the test file that contains the main function?
Yes.
Yeah. Is that because that's the problem that I had when I went to kind of write my test. Is that I managed to install Google Test, but the issue that I had is that I want to keep my main function to execute my Fibonacci function, and I want to have my test just run my test against my Fibonacci.
Yeah, so you have separate executables.
You would okay.
I'd have if my Fibonacci was meant to be an executable that a user can run, then I'll make an executable for that, and I'll make a totally separate one for tests.
Okay.
Okay, so that was last week's homework. The URL is there. So if you want to go look into it in a bit more detail, please do. But now let's move on to some new stuff. Let's talk about value semantics. So many programming languages that you will have used will use what we call reference semantics. C++ is a bit different. Like C, it uses what we call value semantics by default. So what do I mean by that? I mean, very roughly, that copies of variables are distinct. If I create a variable, make a copy of it, and then change the original, the copy is not affected. Right? They're independent. So in other languages, they call this deep copying. C++ does support references. They're very important in the language as well. And we'll go into exactly how we can use references next week. It's very important in the language as well. Whoa. That would have been picked up by the microphone. It's now going to loop forever. So let's have a little look by what I mean. A little look at what I mean by this copies are independent thing. So first of all, we'll create an int. Let's call it a and set its value equal to 1. And now we create another int b, and we set its value equal to the value of a. So what's the value of b here? 1. Easy enough. So now we're going to change the value of a. We're going to assign the value 42 to it. So a is now equal to 42. So what's the value of b here? 1, absolutely. So this is for fundamental types, for built-in types. We have this copying by default. This independent, copies are independent. But it doesn't just apply to built-in types. It applies to standard library types as well. So here I'm creating a string. Remember, a string is not a built-in type in C++. It's a class type, it's part of the standard library, so that's why it has this std prefix. So I'm defining a standard string s, and I'm instantiating with hello, initializing it rather. And now I've created another string called s2, and this one I'm giving the value world. So now I've used this funny plus equals operator. So for strings, operator plus, so the plus symbol means concatenate the strings. And this does concatenation and assignment in one step. So S, after this, has had world glued to the end of it. So S now has the value hello world. Okay? Yeah.
To stop you, when you said B still has value 1, I don't understand why it still has value 1. Because you haven't called B again.
We haven't touched B in any way. So after this step, let's go back right back up here. So we're creating a variable A, initializing to 1. Now we're creating a completely separate independent variable called B. And we're giving it an initial value equal to A's value.
Yeah,
At that point in time.
At that point in time. Okay, so whatever value A has right now, that's our initial value for B.
So you made a copy of A and then put it inside B.
Yes. So now we're changing the value of A.
Yes.
But B is completely separate and independent. Okay. So changing the value of A doesn't reflect on B in any way. They're completely separate, independent variables.
Unless you go and say B again, B equals A or something. Then
if I said B equals A down here, then I'd be changing the value of B.
Sure.
Yes. So this is the way it works for built-in types. But we can do the same thing with library types. So here I've modified the value of S. So this is what we call a compound assignment. So it's doing concatenation and assignment in one go. But S2 still has the value world. We haven't changed S2. We've just read its value and changed S.
So the line there, you could say S equal S plus S2. Yeah?
Exactly that. It means exactly the same thing.
It's just a shorter way of writing.
More efficient.
I don't know if it's more efficient, but
It's more efficient.
Yeah.
There's two operations then, concatenate
and then assignment, and this does it all in one go.
But then using Kate Gregory words, make it simple, not only for the beginners.
Yeah. So a good way to think of this is in terms you are probably already familiar with. So files on your computer, which is an analogy I've used before, right? If you have like a Word document on your computer and you create a copy of that and then you change the first one, that doesn't affect the second document at all, right? Because they're different files. So you can copy a file, change the original, and the copy isn't changed at all. Yeah. So that's, in a nutshell, what we mean by this copies are independent. So moving on, passing by value. So if you know a bit about programming, there are various ways in which you can pass arguments to functions. Pass by value, pass by reference. There are a few others, but those are the two really common ones. C++ by default uses pass by value. And what this means is that the function receives an independent copy of the thing you pass to it. So C uses pass by value, Go does, Java sort of does, but it's a bit more complicated. But this means that when we pass an argument to a function by value, that function receives an independent copy. And in particular, if we modify the parameter inside the function, it's not going to affect the original at all. And conceptually, at least, a function returns by value as well. I say conceptually because there are various optimizations that can take place that will sort of hide this a bit. But conceptually, at least, a function returns by value. So let's have a little look at that. Imagine this was just a declaration in a header file. So what am I declaring here?
Function takes a value, integer value.
Okay.
Returns
So
an integer.
I'm declaring a function called
Add1.
add1, and it takes one parameter of type
Integer.
and it returns.
Integer.
Yeah, awesome. Got to test you on the basics sometimes, right? Make sure you were concentrating. And now, somewhere else in our project, some implementation file somewhere, we assume we've included this header. So we declare an integer j, and we set it equal to 42. And now we call our add1 function, and we give it the argument j. So whatever the value of j is what we pass to our add1 function. And we capture the return value, so this function returns an int. We capture that in a variable called ret. What does this word do here? Auto.
It auto detects the type.
It deduces the type. So it knows that add1 returns an int, so it's going to work out automatically that ret has type int. So I could just have written int here, would have saved myself a character, but I just want to keep you on your toes.
There was one thing which always, at the beginning confused me quite a lot. When you have the function and you say int I, and then when you have the auto rets, and then you put the j, I was always confused. Do I have to call that I? And I don't know, is there anybody having a trouble with that? Do you know what I'm talking about?
Yes.
So for me, that at the beginning, I was like, when you had called the function, there I call it I, but I'm putting in the next line j. Is that important? And basically, that's the representation. So inside the function, you can call that I.
You will call it I.
Yeah. As an I. So it's just conversion of the name, so to speak. Am I explaining this rightly?
Well, in the declaration, it's optional anyway. You don't have to put a name. In the definition, obviously, if you're planning to use it, which you probably are.
But at least for me, it was basically the confusing part. Why it was called int I, but then when I say add1 and I put j.
Think of it this way: it's because you don't know what someone calls it. Imagine I'm going to give you my pet dog, okay, as payment. I call the dog Fido, but I didn't tell you that, and you don't care what it is. You just wanted a dog. So when I give you the dog, you decide to call it Muffin, okay. That is how I would probably represent it.
I'm not sure. Is that going to work?
It's up to him and up to me. The dog doesn't care what we call it either.
We are going into very disturbing
explanation.
There is one question that is a bit related with this one. The function, inside the function, whatever is inside, it cannot see what is outside the function. If I have an A
Correct.
in the main, I cannot see it from
Correct.
inside the function.
Absolutely
So
correct.
that's my A.
Your A is not the same as any A in any other function.
And I can't use anything that is declared outside. I have to do again inside.
There's two kinds of outside. There's a separate scope. So imagine that main has a scope, right? It starts and ends. That's a set because it's a separate scope. No, you can't see that separate scope. They call you, they give you something, you give them something back, but that's so separate. If it's what's called an enclosing scope, so that means
we're going to look at scope.
Are you going to do it? Right.
In a lot more detail.
I'll set it up.
So, sorry, yes.
Very old question. Is there any advantage to using auto instead of defining it as int?
In this case, absolutely not.
But that's the holy
confuses.
That's the holy world.
It's not that I'm trying to confuse you. I'm trying to remind you that auto exists. Because if this function actually returned a standard vector of something with a very long type name, well, I couldn't be bothered to type all that out. So I can just type auto. So I basically just put it there to remind you that it exists.
So also we'll take whatever
It
type.
deduces the type from the initializer. So the initializer, in this case, is a call to add1. We know that add1 returns an int because we've written it up there. So it knows that ret must have type int. It deduces.
So it saves you a bit of typing. Sometimes.
Well, in this case it didn't, because we had to type one extra character, but in a lot of cases, yes, it can save you a lot of typing.
But this is a holy war subject, because some people will say you
Yeah,
should
yeah, yeah.
use auto everywhere, and others will say completely wrong because it will make code unreadable.
Yeah, there are two schools of thought.
And just talking about words, is snake case like the convention in C++?
It really depends on the style. So it's what the standard library uses, Snakecase. The Boost libraries, which are a very well known kind of open source set of libraries, they all use Snakecase. Other projects have different conventions. So Qt, which is very heavily used for doing graphical interfaces, uses Java style like camel case names. I've seen projects that use the like C# style, so upper camel case,
Pascal case.
Pascal case, yeah. So it's really a question of style. C++ doesn't enforce anything. Personally, I tend to go for Snakecase for functioning. I find it easier to read, but that's my preference.
So
the language itself doesn't care.
Yeah, throwing my weight into the ring, as it were. I use Pascal case for naming functions and types like classes, whatever. I use camel case for sort of Java style for members, variables, etc. And part of the reason is because the standard library and Boost use Snakecase. I don't want my methods to look like a library, because if I'm ever using a library or whatever, it becomes immediately apparent that that's a library, that's Snakecase. So it's a benefit.
That's what namespaces are for. Anyway,
using statements, man. People use them.
They're wrong. Where was I? Yes. So we have our local int j, and now we're calling it add1, and we're passing it j. But here's the important thing. Our add1 function we've passed by value, which means that add1 receives a copy of our variable j. So anything that add1 does with its argument doesn't affect our variable j. So our j hasn't changed. It still has value 42. And assuming that add1 does what it says on the tin, this new int that we've declared here is going to have value 43. So now we imagine we have our definition of add1 somewhere else in an implementation file. So this is modifying I. So its argument is called I. It's modifying it. This is a perfectly legal thing to do. You're allowed to change the value of your parameters. So this takes I and it increments it by 1. I could have written this as I++ if I wanted to. I could have written it as ++I. But I decided I could have done it as I equals I plus 1. In this case, I've decided to use this compound assignment again. And now it returns the new value of I. So whatever we were given, we've added 1 to it, and now we return the new value. But the important thing is that this has its own copy of whatever it was given. So when we call it here, we call add1 with this value 42. So then we jump down here, and our I is a new variable initialized with the value 42. And then we modify it, so now 43, and then we return the value 43. So does that make sense?
So that's just one very
yeah.
thing. So that the new I that was created for the add1 function, is that now the 43 to that copy, or does that 42 still exist somewhere else and there's a new 43?
So our variable j here still exists.
Yeah, I get that. But when you pass j to I, you said that there was a new value.
Yeah, so and we've named it I here, and then we're modifying.
So that I is now 43.
Yes.
There is no 42 and 43 of i's.
No.
That I inside the function only lives as long as the call does. So once you come back out and go to that's what it's asking to say. Once you come back out of it, that ceases to exist.
Yeah.
Well,
So this, in a nutshell, is what we mean by passing by value. When we call add1 with this variable, it doesn't modify this variable. It creates a new copy of it for use inside this function. So this is a very useful, very powerful technique because it allows what we call sort of what's known as locality of reference, in that we know that we're not going to affect some other code far away. Right? It can be less efficient because we have to do this copying into the function and then copying out in the return, conceptually at least. But it means that, for example, this is what we call a pure function. It's very safe to call in multi-threaded contexts. The compiler can optimize it very well. So this pass by value is very useful, very powerful. It's not the only way to do things. We can also pass by reference in C++. We have to do something slightly different for that, and we'll talk about that next week. But when you just see something like this is pass by value. So hopefully you've understood that. But now let's find out. So I've got a little exercise for you. We're a little behind time, so I can't give you all that long to work on it. But let's say 10 past. So I'll give you about 15 minutes. And if you need any, well, we're really going to struggle to get to you, but you know,
Screen sharing.
yell at us anyway.
Okay. Jumping in.
Oh, mate. There you go. Shouldn't try and use the C shop rankings. That is very true. Oh, no, you should have quite a C mode. How was it last week, by the way? It was
Not fine.
quite a box of it.
You came in, got some cake and left.
Level of massive hangover instead. It was a nice thing, but basically we sort of ran out of something ridiculous to have it. The place I was at, and everyone was like, "Oh yeah, let's go out for whiskies." Well, I don't usually do spirits. Yeah, I think. Let me confirm.
Is it working?
Yeah, they are. And what happened to the one that the wrong gave back?
I think I got one.
You've got the one that the wrong gave back. Obviously, you should.
Everybody, just a quick thing. We got memory sticks. If somebody's having trouble starting their machine, there's a running like a live USB CD USB memory stick with Linux, and pretty much prepared everything. This is to support these guys.
Yeah, so that's got a compiler. It's a Linux Live USB, so you can boot from that. It's got a compiler and CLine pre-installed, and all the things you need. So you're absolutely
So
browser, editor, everything ready to go.
If you need something like that, we're selling this at £15. We cost of the hardware is something like £7. Rest is for the unit. So if anybody wants it.
Also, you can obviously plug it into anything. So if you work on stuff, It saves to the USB stick. You can plug it into your laptop.
Yeah.
Do some work.
So if you've got a work laptop, for example, you don't want all your private programming stuff on there, you can just boot off that. It'll save just to that. It won't touch your hard drive at all.
It will work on Macs, I guess.
It does work on Macs.
Really?
Yeah. I tested it on my Mac. The only thing you have to do is hold down Alt and then power on to get the boot menu.
I don't have a Mac myself, but I was wondering if they actually blocked running Linux on one of their machines or something.
If you know how to use a Mac, I find it annoying that Macs by default don't show a boot menu. Like the boot, you have to hold Alt and turn it on. But that's it. That's what you have to do. Grab a drink. Drink.
Surprise me. I'm going to end up with... No, I wish I hadn't said that.
She didn't say it.
That's might have unforeseen consequences.
Yeah, it's going to be a tequila shot now or something.
Do you know the name of the dog?
What?
MacBook drink. You got see a shot you got that. At the bottom you put the Tabasco, and on top of that you put like a very sweet raspberry juice, and you fill it up with vodka. It's actually surprisingly nice.
I'll take your word for it.
Try.
Oh, yeah.
Sorry? Thank you. Cheers.
Hello. Nice to see you here. It's a bit sweet. Do you use Jenkins for that?
No, but we use so you've got your name, yes, you know,
The what one? Bamboo. No, they just pay for it. I never cared for Bamboo. It's what? Yeah, I can see.
Is that the Microsoft one?
Dude, I seriously like Jenkins. I love Jenkins. It's got everything under the sun.
when I was looking at
Jenkins pipeline now is amazing. Like, it's got this multi-branch pipeline job. It's Jenkins concept of job.
5 minutes for the exercise.
really. So you define everything in a Jenkins file, similar to what Canvas would do. But then it will
5
create a
minutes
job
we will
per
collect
user.
them. This is the homework.
So as long as you've designed it right, everything, someone's feature branch and do all this stuff in parallel in build. I've been converting my stuff to that.
well, that's your name.
Absolutely.
Oh, yeah. But it must be for
Yes. Yes. Well, you can set a field and it will let them go.
Yeah, I remember you saying. You can't test without many.
On my team, it was
Technically, that's not a unit test. They should be self-contained. They can run on Docker images.
5.
So two of them can run at the same time. Just here with 2 Docker images.
They
No, okay. Right.
I think it's something that doesn't attach to
But you can't run the test without
they
For those parallel storage, you can do them in a container if you need to. But they should be buried. They can have a separate workspace, a separate folder.
But they're not running it. So you want to write names. You should write names.
No, you won't. No, you're never running into Snell code.
Okay.
So you won't skip the build step. If I have 2 builds going, they'll run at the same time, both building the code that they have that's unique to them inside their own workspace. You need to set a certain thing on how much you have it, how many you can pull. Like for a scalable build system, you just attach slaves to doing this. You have like, the main Jenkins master and 40 build slaves.
Yeah. It sounds like
Right, trust me, it's great.
Oh,
Yeah.
And then give back what you
So you find the unit and name, just call me.
So that name has always got to match straight away. Then all you do below is
What does it say to do? Right, oh yeah, right. So this main is a function to make your own function. So
you need a main, into main brackets.
So
You need
right, your return to string strings, the thing that comes first, as you can see, is the return type. So main returns in, you will return your string strings. That's the basic.
You should always have that in your, always have that.
That's okay.
I have to say
That's
that.
string string.
So you have these main brackets.
And then the name comes next.
That's basically it.
Yeah, that's just like that.
Things
Main logic.
I know.
And it just takes the string, so main has parentheses, right? Well, it doesn't take the opposite of parentheses or empty. You want to take them, so you
I'll take
Oh,
you
yeah,
down.
I can
Yeah,
do
I
that.
can
Okay.
Yeah, I'm going
If you come a bit earlier, then you can be,
It takes
Oh, the opposite way around. Be careful. The massive mistake.
no, because we didn't meet last week, and the week before we had really quick.
Does it work?
Probably
No.
hopefully we'll meet this week. So
Your main, your function
So we mean the forget what was the
Oh, okay, yes.
That's right.
And now what we need to do is modify name by adding the string hello. So you're going to pass the name. Hello.
Does that mean so you need to run?
Yes.
Function has to be written out above your name. So the computer
I have
knows
this one.
that.
I don't have this one.
Hello.
And the function is a totally separate box. It's above your name. So
Mhm.
it's just like
I'm sure that I could
Using like this new
2 minutes. 1 minute. According to
So you need to do anything you don't change.
everything
That's why it's something like this. Something like this. That's why you see
So say just say
Just like
yeah, say that, and then
Oh, right, okay.
And then
I've seen that you use the inline and
Time out.
Okay, I'll make it 10 past, so let's have a look. Just wait for Ollie to finish his explanation. So, how many people managed to do this? Most of you. Excellent. Well done. Okay, so here's my solution to this little problem. Well, let's first have a quick look at what I wanted you to do. So write a function called sayHello. It takes a parameter of type standard string called name and returns a string. And this function should append hello to whatever you gave it. Prepend hello, in fact. And then in the main function, I wanted to create a string variable called named me, and then called sayHello, and pass it me. And then just print out the two variables, just to show that nothing has changed. So this was my solution. There are various ways you could lay this out, but hopefully they'll do similar things. So from the top, we have to include IO stream. We're printing things out. We're using this cout functionality down here. So we need to include IO stream, that's input and output stream functions from the standard library. We're also using the standard library string type, so we have to have this include string. So this is just sort of fairly standard stuff, literally. Yeah. So then we have our function sayHello. So sayHello takes one parameter of type standard string called name, and it returns a standard string. And then in the body of this function, we take our name and we set it equal to hello with a space plus name. So this updates our name variable to whatever it was before with hello at the beginning. So I could have done this with plus equals. Not entirely sure why I didn't, but just to show you an alternative way of doing the same thing. I could have done, oh no, because plus equals of course would append to the back. That's why I didn't do it, yes. So, yes. And then we just return this name that we were given. So a couple of alternative ways to do this. You don't actually need to do this intermediate step. You could just return hello plus name straight down here. You could have created a new temporary string here, which is set to hello plus name. There are various ways to do it, but this is the way I chose. And then in our main function, I've declared a standard string called me, and I've initialized it with Tristan. And now I've created a second variable, also of type standard string, named hello me, and I've initialized this with whatever this function gives us. So when I call this function, I pass it the value here. And what this does is it jumps here and it copies this string into a new string called name. So my function, my variable me is copied into this function. So we're passing by value. So name is an independent copy. So we're modifying the copy, we're returning the copy, and this hello me is initialized with the return value of sayHello. So now we have two print statements. First of all, we're printing hello me, which will print what?
Hello, Tristan.
It will print hello Tristan. And then we're printing a new line character just so it looks nice. And then this second print statement is going to print just Tristan, absolutely. Because sayHello operates on a copy. So it doesn't modify this variable me at all. And in fact, we could double check that. We could have declared this variable to be const, because we know that a const variable can never be changed after it's initialized. And yet, if we did that, we could still call this function perfectly well, because sayHello is not going to modify a const variable because it only operates on a copy.
So is everyone clear on the /n? You don't.
So that all makes sense. Do people get something like that in their own solutions? Maybe sort of a few nods, yeah. So any other questions about this passing by value? The function operates on independent copies when we pass by value. It's the really important sort of notion to pick up from this. This exercise was just meant to demonstrate that to you.
Just when you do it that way.
So let's talk about variable scope. Ollie touched on this earlier. I'm going to go into it in a little bit more detail now. So, in the most general way of putting it, scope is a region of code in our program. It's not a very helpful description, but we'll have a slightly more useful one in a minute. And every variable has a scope in which it lives. So there's a region of text in our program. It's called a scope, and a variable lives in that scope. So outside of the variable scope, outside of that bit of the program where the variable is defined, we can't refer to that name. So the scope of a variable, in general at least, it lasts from where we first declare the variable, where we introduce that name, until we leave the scope, until control leaves the scope in which that variable is defined. And importantly, we cannot access a variable outside its scope. If we try to, the compiler is going to say to us, I don't know what you mean by this variable name. There is no variable named this in the current scope.
Maybe a reasonable allegory would be that a scope is kind of like a timeline. Each scope represents the beginning and end of time for a certain thing. And you can have multiple timelines, and certain timelines are longer than others. So you have an inner scope, that scope has a shorter timeline than the outer scope. The shorter timeline can see stuff from the longer timeline. The longer timeline cannot see stuff from the shorter timeline.
So yeah, if you're coming from JavaScript, this scope idea can be a bit funny because well, since I didn't know JavaScript, but from memory, var declared variables don't obey scope, but let I think does in JavaScript. Is that right? Can anybody tell me? No.
I guess it's a little more complicated than that. Check, I remember that.
Yeah. But with let you can't.
So let's be more specific. So if you find a let specific word like an if, so if you have a function and you define like an if block inside that function, then you use let, it will be specific to the if block.
Okay. So in C++, all variables behave like that. There is no equivalent to what var does in JavaScript. So I know last time we did this, we had lots of JavaScript programmers, so rather fewer this time around apparently. But let's have a little look at an example of what I mean by variable scope. So in a function definition, we create a scope. So in general, or you can always think of it if you want, a scope is defined between a pair of curly braces. So we have our function definition, I've just called it func, and it creates a new variable here, I. So I here is in scope, as we say. So we set the value of I equal to 0, and we create now a new variable, also an int called j. So j's scope begins here. I's scope begins when we enter the function. J's scope begins here. So now here we do something funny, and this is a bit strange, but C++ allows you to do this. In fact, C does as well. You can open a new scope wherever you like. And you do that just by putting a curly brace or a pair of curly braces, in fact, as we'll see. So we've created a new scope here, inside an inner scope. So inside our function, we've got an inner scope. So now we create a new variable called k. So the scope of k begins when we declare it. But this is an inner scope. So our I is still accessible. So we can modify I. Here we're modifying it to set it equal to whatever value k has. And in the same way, j is still in scope. But now we close this block here, close this block between these curlies, so we're closing the inner scope. And at this point, k's scope ends. So when we're down here, there is no variable called k. The variable called k only exists between these curly braces, or in fact between this line and this closing curly brace.
Because that's what is inside.
Yes, exactly. This is what we call an inner scope. So if we now try to modify the value of k, we're going to get an error. The compiler is going to say something along the lines of, there is no variable named k anymore. It doesn't exist.
So scope purely controlled by the brace.
Yes.
Okay, so just purely because I and j's brace, there was no closing the brace.
There is no closing brace now.
Yeah.
Yet.
Yeah, and that's the reason you can then call them inside the inner scope.
Exactly.
They still exist somehow.
Exactly.
The closing brace is the most brutal part of C++. It kills all variables.
So if we try to modify k here, this line here is going to be a compile error, right? If you try and compile this function, it's not going to work because of this line. You're going to get an error message, as I say, something along the lines of, there is no variable k.
Your code is not valid.
Exactly.
It's not valid either.
And then we've reached the closing brace of the function. So at this point, the scope ends. We've closed the block, so I and j are no longer in scope. So does this make sense to people? This is, depending on where you come from, this is either really, really obvious or a bit weird, right? So
I mean, this is what I meant by timelines, right? The longest timeline is the whole function, where I is, and the shorter timeline is that smaller one where k is. Makes any sense. K dies first, and j and I die last.
So what's the usability of that? Even in that, I mean, obviously a proper program it has different uses, but what's the sort of the
Mutex.
Huh?
Biggest one for that is mutex.
So why do we do this?
Yeah, what's the biggest benefit of having this code?
Because scope controls variable lifetime in C++. So C++ doesn't use garbage collection. So many, probably most other languages you might have used use some form of what's called garbage collection to manage memory. So if you used to Java, say, you create a new variable with new object with new, and then you just forget about it. And when you finish with it, sometime after you're done with it, the garbage collector will come along and it will delete that thing for you and reclaim the memory. And JavaScript works the same way. Python effectively works the same way. It actually uses reference counting. Doesn't really matter. It manages it automatically. Right? You don't have to think about it. C++ doesn't have a garbage collector. Which means that, in principle, we have to manage all the memory ourselves. But what's a really big help to us is that we can use scopes to manage our variable lifetimes. So our variable comes into being when we declare it, and it ceases to be when we leave the scope in which it was declared. So this is probably the central concept in C++, probably the most important thing to get a handle on in modern C++. And it goes by this rather silly acronym, RAII, stands for Resource Initialization. Resource Acquisition is Initialization, which doesn't really tell you what it is. I prefer the term scope-based resource control. Right? If you're into Rust, Rust also uses this RAII, as it doesn't have garbage collection, it uses RAII. It's a really, really powerful technique.
So essentially just creating temporary variables and then getting rid of them.
Yes. Yes.
And you free them.
Absolutely. So when we declare a variable inside a function, we call that an automatic variable. There are other types of variables. There are static variables.
Automatic storage duration.
It has automatic storage duration. That is, it comes into being when we declare it, and it is automatically destroyed when we leave the scope. So you can also have static variables which are destroyed at the end of the program. You can have thread local variables which are destroyed when the thread you're running in ends, and you can have dynamic variables which are destroyed when you tell them to be destroyed.
A function is not an inner scope of the main program.
Yes, it is. Yes, it is. So there is a global scope which is outside of all of your functions. Right? That's called the global scope. And if you declare a variable in your global scope, which is a bad idea, but it's possible to do, then you can refer to that variable inside your function. Any function in the same CPP file.
Bearing in mind that it's per file. So if I enter an int globally in my main.cpp, I can't just use that from another .cpp file.
Yeah.
So I have to do a special declaration in a header file that they can share to use that simple global.
So
Don't use global.
it's a very bad idea, but in a sense, yes. A function is an inner scope of the global scope. Or when we come to namespaces are their own scope. We're not going to discuss namespaces yet, but a namespace is a scope, and a function is an inner scope of the namespace. So function parameters, we've actually just seen that. Function parameters are also automatic variables. They come into being when we enter the function, and they're destroyed when we leave the function. They have automatic lifetime. This thing of having automatic lifetime is not the same as the auto keyword. By the way, the auto keyword is for type deduction. This is referring to this. We don't need any special word for automatic lifetime because it's the default. And this is really the absolutely key one, is that when you write your own types, you can declare a special function called a destructor that automatically gets run when the variable is destroyed, when we leave the scope in which it was declared, right? And this is the absolutely key step. So the combination of automatic lifetime and destructors means that, for example, we can do exactly what standard vector does, which is to allocate some memory, ask the operating system, can I have some memory? Store the variables in that memory, and then when we leave the scope, when the vector is destroyed, it runs this special function called a destructor, which releases that memory. So that's why we don't need garbage collection in C++, because we have this combination of scope-based resource management, scope, or RAII as it's often known, and destructors.
But why would you want to do it manually when it's automatically?
Well, quite.
Because you don't know when you need to destroy it.
But wouldn't it automatically be destroyed when you've left that scope? So why would you need to then call a destructor function to maybe I have to display some data to the user, and they're only done with it when they click a button to say I'm done. But they might, before they click that button, right, they might want to be able to interact with the data and change things. So if I have to I will call into the OS, I have to allow the user interface to remain interactive. So I have to return from functions in order to do, say, processing of the user interface, handle their clicks and key presses. So return from a function. So
then the object, the data is now has to have what's called this dynamic storage array. And
You should initialize first and then you must destruct it when you go.
There's something called smart pointers which allow you to do this in this still clever way. The point is that you have various parts of your code where you keep like, so I'm using this, I'm using this. Sure.
So let's have a little look. This is going to look strangely similar to what we had before, except I called it function this time instead of func. Let's have a quick look at when the lifetimes of various variables begin and end. So i's lifetime begins at the point at which we enter the function. So int I, this is a new variable, a new value. Remember, it's received a copy of whatever we gave to this function. So i's lifetime has begun as soon as we enter the function. So now we create a new int called j, and we've initialized it to whatever value we were given. So j's lifetime begins here. Begins at the point at which we declare it. So now, again, we're going to use this curly brace to create an inner scope. I'm going to create a new int called k. I'm going to initialize it with whatever j was plus 1. And so k's lifetime begins at the point at which we declare it. So now we have an if statement. If k is equal to 1. So that's going to be true if j was equal to 1, which is going to be true if we were past 1. If j was equal to 0, which is going to be true if we were past 0 into the function. So if k equals 1, we return immediately from the function. This is a void function. It doesn't return a value, so we don't have to give a value. We can't give a value to the return statement. So if k is equal to 1, we enter this block, and then we immediately exit from the function. So we leave this scope. We leave this scope. It's going to be closed down here somewhere. So when we leave this scope, k gets destroyed, and then we're going to leave the function scope. And at that point, j and I are destroyed. But assuming we didn't enter this block, and we didn't hit the return statement, we're going to pass on to this curly brace, which is going to close the scope we opened here. So any variables we declared in this inner scope have their lifetime ends. So k's lifetime ends here, k is destroyed. And then we close the function scope. So first of all, it's going to destroy j, and then it's going to destroy I. So one important feature that I didn't mention is that variables in C++, a cast iron rule, variables are always destroyed in the reverse order that they're created, automatic variables. So in this case, I gets created first because that happens on function entry. Then j is created, then k is created. And if we hit the return statement, they're going to be destroyed in the reverse order that they were created. So it's going to go k gets destroyed, j gets destroyed, I gets destroyed. For a sort of simple example like this, the order doesn't matter, but in more complicated cases it can matter. And it's one of the strengths of C++ actually, that this is really well defined, that it always happens in the reverse order that things are constructed. Yes?
The return is leaving both the scopes. It's called the function.
This return statement leaves the entire function. So it doesn't just leave this. It doesn't just leave this scope. It leaves the entire function.
Even if before the last line, if you add I equal to 5, then it won't be.
So if we had I equal to 5 down here, that would never run. If we enter this block, this returns at that point. Yes.
I'm just wondering, if instead of the return get a break, would that leave the scope? The error scope?
I don't think break is valid there. Is it?
I think breaks valid where?
In an if statement, it'd have to be a switch.
No,
wouldn't it?
yeah, it would have to be a switch case or a while loop or a for loop.
Yes.
So return what is what there's void in the beginning.
Sorry.
So the return, it destroys the function because it starts as void. Or it's always void like that.
No, return always leaves the function.
It's a short circuit, as it were.
Yeah, just
cuts
bang.
everything else out.
In this case, usually we need to return a value from a function. So if this function returned an int, say, we need to say return and then a value, like return 3. In this case, the special type void means this function doesn't return a value. So a function in C++ always returns either 0 or 1 values. If it returns 0, we use the keyword void, and then we use return with no value there. We just say a plain return. So again, this is very, very similar to what we saw before. We got this little wrinkle with return this time. But it's very similar to the scopes example. So what I'm trying to convey here is that variable lifetimes, automatic variable lifetimes, are controlled by scopes, which is probably the best and most powerful feature of C++. I'm not exaggerating. This is literally the best thing about C++. Doesn't look like much here. In fact, it looks like it's pretty obvious, right? But honestly, this has far-reaching consequences, and it's something that's really, really, really important to kind of get a handle on and understand how it works.
Does it help make it a fast language?
It does, in the sense that we never ever hold on to any resource for any longer than we need. If you use this technique properly, as soon as you have finished with something, it's gone there and then. So we don't have to wait around for the garbage collector, which might be running on another thread or whatever. We don't have to wait around even if it's a few milliseconds. That can be really important if we're doing, if we're writing a game or something. If we're doing high frequency trading, you can't afford a few milliseconds to wait around for that memory to be reclaimed. In C++, this model, it's reclaimed instantly, there and then. As soon as we leave the scope, by whatever means, either by control flow going off the end of it, or via a return statement, or there are a couple of other ways to do it. As soon as we leave the scope, that is destroyed there and then.
Objects last exactly as long as they are needed.
Yes.
Which means you have to think about how long they need.
So is this making sense to people? Yeah? Excellent.
Could you mentioned destructors before.
Yes.
Can you define a variable and destruct it straight away? Will it work?
So destructors are automatically run if a variable is of a type that has a destructor, then that destructor is automatically run when we leave the scope, and there is nothing you can do to stop it. Right? It will happen.
You can also call it directly. Run twice, and that's really bad.
Yeah. There is a way to manually call destructors. Unless you really know what you're doing, don't do it because it causes massive problems. Is there a way to immediately create a variable and just never use it for anything? There is, but it wouldn't be of much use, would it, if you're immediately creating and destroying something?
Well, it's useful for comparisons of types. Like, for example, if you have a type, it's a concrete example of boost AZO address. If I want to see if it's default constructed empty object, if I want to see if it's an empty object, this actually came up today. I just said, just don't convert the object to a string and then see if it's the 0 address. Compare it to address curly braces.
Okay, but in that case, you're creating a temporary that's lasting for the length of the statement. That's not immediately being destroyed. That's lasting for the length of the.
That's a PR value is the shortest lifetime you can basically do. The PR value, obviously, about auto and out.
Look, let's just focus on this stuff for a minute. Right. So does this idea that the lifetimes of your variables are controlled by the scope in which you declare them, and when we leave the scope, variables get destroyed. That, in a nutshell, is what's brilliant about C++. So, if you've got that, if that makes sense to you, brilliant. Because honestly, I'm going to... People like John over there who've been through this before will know that I bang on about this all the time. This is literally the best thing about C++.
Yeah, and it sounds really simple.
Yeah.
At the moment, it isn't.
Oh, it really is.
Yeah, but if you keep it in your mind,
Yeah.
if you don't, you
Yeah.
can get into some problems.
It's destroyed already.
The more I guess things get complicated, the principle is there. It's just
Okay, so that was scope, that was variable lifetimes, that was really important fundamental for things we're going to do later. But now, as a wise man once said, now for something completely different. So our if statements. In fact, you've just seen one. And if you've used any programming language ever, you will probably be familiar with if statements.
So I have to move to catch a train.
No problem. Thank you for coming. I hope you can manage to squeeze your way out.
Squeeze and squash.
Yeah. It's really athletically run across the table. Go on.
Shouldn't have had that pipe last week.
I know.
As it gets past the back.
Yes, guys.
Okay. So one of the, perhaps the most fundamental statement, control flow statement, is if. So if condition, if something, then we enter this block and we do something. And so condition is going to be a Boolean type, so it's going to be true or false. So if the condition is true, we execute the statement in between these curly braces, and if the condition is false, we skip right over it. Nothing in these curly braces is ever run. Right? Pretty familiar if you've done any sort of programming before. It's pretty hard to have a programming language that doesn't have an if. Right? So for those, you guys probably already know this. Last time we did this, we had a question. Does condition, does it have to be a Boolean? How does it work? It's actually, it has to be what people call truthy, which means we can convert it to a bool. So if it's a pointer is either null or it's something, right? If it's an int, if an int is 0, that's falsy. If it's anything else, then that's truthy, right? If you can convert it to a bool, a true or false value, then we can put it in this condition.
For strings and chars, you would need to put them in double quotes. Because for ints and numbers, you'll be just if equals.
If I equals 3 or whatever, yeah.
But for a string or something, you would need to put the string that you're trying to compare to in quotation.
Of course, because if you didn't put the quotes, it would think C++ would think it was a variable name, or it would think it was the name of something. Yeah.
You can't compare to one of them have to be a stood string. Couldn't do like quotes hello equals quotes. Because those are not actually they're pointers to.
So, oh, that should be blue. I don't know why it hasn't come up blue. We can also, again, pretty familiar, we can use else if to test the second condition. So we start off here, if this condition is true, we do this, and then we leave. If this condition is false, then we test this one. So this condition only ever gets tested if this one is false. And if neither of them are true, we skip right to the end. And you can have as many else if statements as you like, and they're tested in order. Make sense? So first of all, we test this, then if we had more else ifs, we test them all in order. And the first one that matches is the one that gets executed. So again, nothing particularly strange here if you're familiar with the way if statements work in, as I say, pretty much any other programming language in the world. And then again, we can have a final else statement. So this is else if. It's written as 2 words in C++.
Because it's actually 2 separate things.
Well, some languages have elif.
PHP has else and it's a single word, but logically it's the same effect.
So we can have a final else clause and this always matches if none of the others do. So we test the condition. If that's true, we do that. If that's false, we test this one. If that's true, we do that. If that one's false, we jump to here, and then we execute the thing in the else block.
Same as else if true.
In fact, yes. So we could do else if brackets true. True is always true, so that block would always execute.
Do you need all those 20 braces now? Thinking about the scope thing, wouldn't they be destroying every single variable?
Right. So this is a very interesting. So you remember I was a bit hand wavy about what exactly a scope is.
No, but
Okay. So I could have just said a scope is a thing between 2 curly braces, and that would have made life a lot more simple. And 99% of the time, that's correct. But it's not 100% correct. So, actually, no, we are allowed to omit, we're allowed to put any single statement after, let's say, after the else.
Yeah.
We could just put a single statement in there.
I equals 5.
Yeah.
Yeah.
Semicolon.
Right, so this brace just lets us do multiple things where we would have to. Yeah.
It's not destroying, so say at first else. First
okay, if we declared a variable, so these things are creating a scope.
Yeah.
Right, so if we declare a variable in here, that variable is not accessible in this branch, it's not accessible in this branch because, well, for a start, we're only ever going to execute one of them, right? Yeah. But also, as soon as we leave this block, it gets destroyed. Yeah, absolutely. Yeah, awesome. Yes. So any variable we declare in one of these blocks is destroyed when we leave that block. Yes. Now, your question is, do we actually need these? If we have just a single statement, we could say if condition, if I equals 3, if I equals 3, we'll set I equal to 4. Right. We could do that all in one line and omit the braces. I think it's kind of bad style. Because, well, it is bad style. Yes.
Unless it's something super, super trivial, and you're not nesting if statements, you literally have a very, very simple statement and a very simple operation to do in that case.
So if you have multiple segments, you can compile one and compile.
No, well.
No, it would. You could omit those braces from all of those as long as every single one.
As long as all of these were just one instruction.
Yeah, that's what I mean. So
okay. Now here's what here's the confusing thing, right? Because you're allowed if you don't use braces, you're allowed one instruction. Okay, if that one instruction is to create a variable, that variable is still destroyed.
Yeah.
Right. So it's as if that variable existed in its own little scope.
Even without this.
Yeah. So if that one instruction you had was to create a variable, you couldn't access that variable down there. Yeah.
So if you have a 2-line instruction, yes, and you don't use the curly braces, then the next line is just outside the if statement. Am I correct?
Yeah. It is.
So it could be very, very confusing.
It would cause an error in this case.
So this is basically just always use braces and you'll never run into trouble.
Unless you're super confident, just don't.
Even then, just use braces because the next person who reads your code might not be super confident.
Also, if you're super evil, don't do the curly braces. Put a second statement and indent it anyway. So
yeah.
What about variables created outside of these statements?
So up here, if we create a variable,
outer scope.
Yeah. Maybe someone else can say. If we create a variable up here, we say int I equals 3.
Yeah.
When we're in this block,
or any of them,
or in this one, are we allowed to access I?
Yes.
Yes, we are, because these are an inner scope of our. We imagine this is inside a function. So this is an inner scope of our function scope.
So just getting my head around this.
Yeah, no, this is great.
Actual real thing. So say in the first signal it's A equals B plus C. So now you've done some calculation. Now
Up here, yeah?
No, before.
In
so,
here,
Yeah.
yes.
So now you've said the statement is A equals B plus C. So you've declared something to A, or you've done.
You've modified A.
Yeah, you modified A. But then you would want to maybe it's a function that you're passing in out of value of A. So say at the bottom it's like return A, the last thing after the if statements. So when you leave that if condition because it's being met and you've now modified A, would that be passing A through to the return or no?
Yes. So if A is declared up here, so A's lifetime begins in here. A is still alive when we're inside this block. So we modify it, and then A is still alive until we leave the function scope, or leave whatever scope it was declared.
But if it wasn't, then it would be destroyed.
If we declared an A in here, then as soon as we left this, it would die.
Ask you something. In this homework that you did for today, I had if function, if statement, which I asked the user, would you like to give me your seeds instead of using 1? And I created the seeds variables inside the if statement. Then I gave them value. There is an else, it's a bit. Either the value that the user gave me or the 0, 1. But they are inside the if statement. After all of this is finished, I recalled the Fibonacci function passing seed1 and seed2. So how is it able to see my variable that I created inside the if?
I'd have to look at your code because if you create the variables inside the if statement, you certainly can't access them outside. So I'd have to have a quick look at the code to see exactly what's going on. Okay, we have 8 minutes left, so it's a good time to set you guys an exercise, and you can have a bit more of a go at it before next week.
Don't finish. Buy the beer for everybody else.
So last week I set you Fibonacci, which is just one of the absolute classic intro programming exercises. Today we've got another one. We're gonna implement FizzBuzz. Do people know what FizzBuzz is? No. Well, it's one of the classic interview questions, actually.
One of the worst interview questions.
Well, yeah.
Don't work anywhere that does this.
Yeah, it's a classic interview question, actually. But first of all, just a little bit of an introduction, a helper. Right, so we have this modulus operator in C++, well, C as well. And it returns it's a mathematical thing, it returns the remainder after dividing one int by another. And what it's primarily useful for is to see whether one int is exactly divisible by another. So if a number is exactly divisible by 2, then that's an even number. So 2 is exactly divisible by 2. So that is even.
Calculates the remainder.
Yeah. So 16 is exactly divisible by 2. So if I divided by 2, so if the remainder is 0, then I is even. And otherwise, we print I is odd.
Remainder.
Yeah? Going back to doing division at school.
If I do 3 divided by 2, then 3 goes into it once, with 1 left over.
Okay. So this modulus, or this form of it, seeing whether one integer is exactly divisible by another, is something you're going to need to use for this exercise. So it looks a bit involved, hopefully not too involved. So this is what I'd like you to do. And then, well, you've got another 5.5 minutes if you want to work on it. I reckon if you're really good, you could do it in 5.5 minutes. But otherwise, more realistically, if you want to take this away, speed coding. Yeah, and this is a really, as I say, this is an absolute classic interview question. It's like a pre-screening, do you know what you're talking about kind of thing. So, good to memorise it anyway.
Don't forget our YouTube is live streaming this, so you can just go to youtube.com/CPP London Uni and watch this whole thing again. Come home and pause it on the last whatever minute this is.
So it's basically getting you to practice with if statements and else if and else and things like that.
Does C++ have switch statements?
Switch it does, yes. Yes.
You can even go to it.
Yeah, they're slightly strange beasts, and they're a lot less useful than in things like Swift, because you can only switch on an int.
Is it true, like, well, at least, well, definitely in JavaScript, I think, I can't remember how it works, but if you use an if statement, you will check every single close that you have there, but switch will accept as soon as it hits the first one that matches.
No, so if in C++, if will only test the conditions as far as it needs to. So if the first condition matches, it won't check anymore. It will not check any of the else ifs.
If is a linear search, effectively, right? Is it this one? No. Okay, next one. Is it this one? No. Okay, next one. Whereas a switch case statement is what is implemented generally in C++ by what we call a jump table, which is also why a switch case doesn't work on any old type. You can't have a switch case of strings. It has to be something numeric or an enum. So what it actually does is it turns your, if you imagine...
If you do like a switch true, and then you check.
Well, that's just boolean, that's either true or false. It's better represented with, say, an integer, which could be 0 to 4 billion, right? To the power of 2. They're unsigned. You know how you index an array, right? So let's say I have an array of 10 elements. I can get to I can access the fifth element. It takes the same amount of time to read the fifth element as it does the 10th element. Right? But you just go straight to it. And a switch case statement is the same logic, but it's for code. So I pass it a value and say case 5, case 1 million. It doesn't matter how big that number is. It just jumps. The CPU just jumps straight to that place. And that's implemented by the compiler as what's called an instruction offset. So it puts it at a special place in memory and just says, okay, we have this memory address and we're executing right now. You want case 1 million, just add this on to it. Go straight there.
You have a question?
When will you release the slides?
Sorry?
When will you release the slides?
I always forget, and I always need a prod. But I will. If somebody will prod me, I'll do it tomorrow because I can put these straight on.
You can also see it on YouTube anyway.
Well, then you have to sit through 2 hours of me nattering.
There's
so
skipping, you can actually skip through it.
I wouldn't wish that
Go
on
straight
anybody.
to it. Yeah. Oh, look, it's the UB. It's that UB. Go to.
Hang on.
I'm actually asking right now. I think it is. I think it must be.
Why do you think it is?
Because we go out of scope, so j no longer exists at all. We increment I in order to force the if statement, and then jump to the label. So we've got.
Is that compile acceptable?
Yes, it won't compile if you assign j in the same line. If you do in j equals 4, it won't compile.
That's probably your answer.
I think it's UB.
Okay. Well, nobody wanted to spend their last 90 seconds working on that then. Well, that's just fine. Okay, thank you everybody for coming. Sorry we were so cramped in this tiny little room, and it's boiling hot because there are lots of people in here. So thank you all for listening to me patiently for 2 hours. I hope to see you all next week. Please register on the website, because the earlier you do that, the more likely it is we'll be in a nice big room. Secondly, we're going to go for a drink in the pub around the corner. If anybody fancies joining us, that'd be awesome. And yes, that's it. Hope to see as many of you as possible on Thursday.
Make sure you buy these guys at least 1 beer. Get them drunk.
Ah.